Cambridge Computer Science, Chapter 7, Algorithm Design and Problem Solving. Chapter 7 introduces you to programming. Actually, starting from Chapter 7, questions in Chapter 7, 8, 9, 10 will appear in Paper 2. And Paper 2 is called the Problem Solving. Okay, so Chapter 7 introduces you to programming, and Chapter 8 is actual programming, and both of them, they occupy most of the marks for Paper 2. And then what else in Paper 2? There will be a very, very small and easy chapter that is database, and this chapter is very, very known, very well known for candidates who did ICT. And then there will be another chapter, chapter 10, about logic gates. Okay, and all together chapters 7, 8, 9, 10 compose Paper 2, which is half of the marks, which is 75%, 75 marks out of 150. Okay, so please let us pay attention. Actually, we will not start programming. We will give basics occasionally. What you have to really study is what is called pseudocode. And this is false coding. Okay, actually, I am bringing into this notes bits of programming in Python just for clarification. Also, I have a website that can somehow run pseudocode instructions. Pseudocode instructions are not for being run. They are just for being written. Okay, I will actually right now, you don't know what is meant by a pseudocode. Okay, let us start with this and let us put much basics as much as possible, and I hope everything will be clear. Okay, so chapter 7, algorithm design and problem solving. Program development life cycle. This is very well known for candidates who have taken ICT. In ICT, we have what is called system development life cycle. Here we have program development life cycle. There are very little differences between both. It is the concept that when you like to create a program, you just don't go and create it. You have to do analysis first. What is analysis? Study the requirements of the company or the nature of the problem you are trying to solve. So with the analysis, you study the problem or study the situation of the company you would like to create a program for. So first you start with analysis. And then you go to design. What is design? Create designs. So what are designs? So draw with on a piece of paper what will be called flow chart of the program. This is what is called flow chart. Okay, write some instructions in a form that we will later call pseudocode, or just draw the structure of the program by splitting it up into smaller parts. These three tools will be used in the design. Okay, so after you are done with analysis, that means studying the situation, and then you create designs. So you draw diagrams like this. Then you go to coding. Coding is about writing programming code. And I have here, for example, print hello world in Python. Okay, I will be showing you bits of Python today and also bits of pseudocode. Okay, but actual coding is actual writing. So I have here print hello world just for an example of a code written in Python. Okay, so you do analysis, then design, then coding, and afterwards you do testing. You have to test your program that it really works as intended. Okay, you have to put lots of test data. In our study, we will study what is meant by test data. ICT candidates already know what is meant by test data. Normal test data, abnormal test data, extreme test data. Okay, Okay, let us go and read. Okay, we are left with maintenance. Happily, maintenance is not included in the O-level syllabus. It's only in the 8 AS syllabus. It's only here because I got that diagram from the AS textbook. But we will not be doing a maintenance. Okay? Okay, so let us go and read what is written here. I hope I have managed to explain it properly. So program development life cycle. The program development life cycle is divided into 5 stages: analysis, design, coding, testing, and maintenance. The program development life cycle discussed here in O-level computer science will be limited to analysis, design, coding, and testing, and nothing about maintenance. It is not mentioned in the syllabus, but it do exist. Okay? Okay, so let us study first the analysis, because there are some details I didn't say yet in the analysis stage. Before any problem can be solved, it needs to be clearly defined. So you just state the problem, formulate the problem. There is no problem, there is a task that you would like to achieve. Okay, set out. This is called requirement specification. You study requirements of your clients. Okay, for the program. The analysis stage uses abstraction. Let us study this. This is new in the O-level computer science, and this is in the AS computer science. Everything I say in the O-level will benefit you in the AS and the A-level in general. The analysis stage uses abstraction. What is meant by abstraction? I will be saying right now. Abstraction means filtering out information that you can find unnecessary and only focus on information that you will find necessary, because you like to create a program. So you put variables for the data that are really necessary toward achieving your results. If some pieces of data are unnecessary, filter them out so that you can focus on what is important. This is called abstraction. And also decomposition. What is meant by decomposition? Splitting the program into smaller tasks so you can easily handle all these tasks. Okay? To identify exactly what is required from the program. So you do abstraction and decomposition to be able to find what is required from the program. Okay? Okay, what is meant by abstraction? Abstraction keeps the key elements required for the solution to the problem and discards any unnecessary details and information that is not required. This is what is meant by abstraction. What is meant by decomposition? You split your task into smaller tasks, and then you keep on splitting until you get to all the details you want. The composition breaks down a complex problem into smaller parts, which are then can be subdivided into even smaller parts that can be solved. Okay, what next? What next? We are still in the analysis stage, and please trust me that I'm keeping a close eye on how exam questions appear in the in recent past paper, because recent past paper they said, okay, what is done in the analysis stage after doing abstraction and decomposition? The components parts, after you decompose your program, you find that any program can decompose to the following components. There would be some inputs, there would be some processing, and definitely there should be some outputs, results. And occasionally you may need to store values for future use. So any problem or any program may be decomposed into inputs. What is put into the system? Processing or processes. What processing or calculations need to be done on that data to produce the output? And then output, what will be printed on the screen or printed on paper? Storage, what needs to be kept for future use? So this is a very good example about decomposition, and this is how decomposition appeared in last year's exam. They asked about components of any system. This is a general decomposition of components of any system or any program. Okay, now we are done with the analysis. Okay, and these are new topics in the O level, and they show quite often now in recent past paper. Okay, and it's very, very important to know this if you will or you are already doing AS. Okay, then we come to design. What do actually our whole syllabus for the O level will be in the design stage. You will need to split your program into parts, and this is called top-down design, and this is done in the design stage. And this diagram very soon will be called structure diagram. Okay, so you try to split your program into components. Okay, when you split the program into smaller parts, they become easier to create. Okay, we will be calling these modules, we will be calling these procedures and functions and so many things. Okay, and then you may need to draw or solve flowcharts. This is a diagrammatic representation of the design of the program. Okay, so you will need to actually chapter 7 is all full of flowcharts. You have to solve them, and later on you will need to draw them, flowcharts. Okay, and pseudocode is false coding. Okay, it is like expressing the steps for your program in a very simple way. Okay, these three, they are in the design stage. And actually, all you need to do in programming in O-level computer science will be flowchart and pseudocode, primarily pseudocode. Okay? Okay, so you will live all your syllabus doing pseudocodes. Okay? So design the program specification from the analysis stage is used to show how the program should be developed. So now you are considering how the program should be developed. Okay, this can formally documented using structure charts. These are structure charts that show the structure of the program, how the program can be split into smaller components and the relation between those smaller components. Okay, okay, you may say that the structure chart is part of the composition. Yes, you are true. However, in the analysis stage, you do the composition in order to be able to go through all the details and understand what is necessary from the program. So here you do the composition to understand what needs to be solved. Here you do top-down design. This very soon will be called top-down design. Okay, you do top-down design by actually splitting the program into smaller modules that are going to be programmed separately and then tested separately and then combined together toward that solution. So you are very clever in your comment in that the composition and structure charts, they look very similar. Yes, you are correct. However, I do the composition here for the purpose of understanding what is required. I do top-down design here in the design stage to start developing the program. Okay. However, they look very similar. Okay. So in the design stage, you will be doing the structure charts. I will be showing structure charts in a moment. Okay. In your design stage, you will be doing flow charts. This is a diagrammatic representation of the processing involved in the program. Okay, and this is prior to coding. So drawing the flowcharts will be prior to coding. Writing pseudocodes will be prior to coding. Actually, in your O level, you will never be coding. You will be just writing pseudocodes or flowcharts. Okay? So this can design can be formally documented using structure charts, flow charts, and pseudocode. Okay? Later on, we will spend lots of time doing flow charts and pseudo. Okay? And then we come to coding. Coding is actual writing the code for the program using a suitable programming language. But because you will be sitting for paper 2 as written paper, you will not be sitting on a computer. You will be doing pseudocodes instead of actual. Okay, so coding is writing the program code, the program or set of programs. Set of programs if you have decomposed the program into smaller parts. Okay, set of programs, okay, is developed. Each module, so this is a module, this is a module, this is a module. When you do structured diagram, on I'm sorry, when you do top-down design, you split your program into modules. Okay, okay. Each module of the program is written using a suitable programming language and then tested to see if it works. Okay, and this is a very simple program. I will be running Python codes for you right now. I will be running Python codes for you just to see how things would go. Okay, but actually you don't need to study exactly Python. So what I have here on screen is Python running within PyCharm. And this is the environment students will be using when sitting for paper 4 in the A2 of the A-level computer science. Here in Egypt, the programming environment that we'll be using for paper 4, because it's going to be practical paper, is Python within PyCharm or PyCharm on top of Python. Okay, PyCharm is an editor, is an integrated development environment that is helping you comfortably write codes and warning you of mistakes. Okay, I will just take this as this single piece of code, and this is the very first code programmers practice doing. So print quotation hello world. So when I run it, it just shows hello world on the screen. Okay, what is the benefit of this? Nothing. Just to see that your environment is working, because there are things going in the background. Maybe in chapter 4 in computer science, we will study about compilers and interpreters. This is an interpreter. It translates the source code. This is what is called source code, will be translated into machine language instruction by instruction. And then the output is shown on the screen. Okay, so this is the first program that it says just hello world, and that's it. It just print instruction. They always make fun of it, that this is the first step a programmer need to do, just to say print hello world. Okay, I'm showing this just to clarify for you what is meant by coding. This is the very first step towards code. And then we come to testing. Okay, after you write the code in PyCharm or whatever programming language, you need to test it thoroughly, because while coding, you will be producing numerous mistakes. I would like that every now and then you stop and test, especially if you're doing a big program that is split into modules. You test module by module and make sure it is working. And there is lots of saying about testing. There is what is called normal test data. There what is called extreme test data and abnormal test data. Compute ICT candidates know this very well. This will come soon, maybe after a lesson or two in chapter 7, when I talk about normal test data, abnormal test data, extreme test data. And now I'm just mentioning them, and that's it. And definitely after testing your program, probably you will discover some errors, and then you will fix these errors and then retest the program again. And if you are doing modules, you test a module and make sure it is working fine, and test the other module, that is the other part of the program, and make sure that second part of the program is also working fine. And then you combine parts together and then test that they are functioning properly together. Okay, this is what is meant by testing. So the complete program or set of programs, if you are doing modular program, is run many times with different sets of test data: normal test data, abnormal test data, extreme test. Each module is tested separately Then modules are linked together and tested. Modular tested are conducted. So you test every module separately. And then code amended if it needs. And tests repeated until module performs as required. This ensures that all the tasks completed work together as specified in the program. And then you combine and test them together. This is what is meant by testing, and there is nothing to say about maintenance. It's not in your syllabus. Officially, it's not in your syllabus, so I will not discuss it here. Okay, let us look at this example because this showed last year. Okay, so the exam was asking you to connect the description to its proper stage name. You have analysis, coding, design, evaluation. There is nothing here called evaluation. Okay, you connect it to nothing. This is a question. Okay, so it's putting here evaluation just to examine you. And testing, developing an algorithm to solve the problem using structure diagram, flow chart, and pseudocode. This is design stage. And we will spend all our syllabus writing algorithms to using flowcharts or pseudo. Okay, detect and fix errors in the program. This is called testing. Identify the problem and its requirement. This is the very first stage, that is analysis. Write and implement stop instruction to solve the problem. This is called coding. Okay, so if you can successfully connect them, you earn 4 marks, easy marks. I would like you to earn all marks available and get ready for the big challenge, because the biggest challenge in paper 2 is that scenario question that is worth 15 marks. Okay, we get ready for it with preparation and study. Okay, so now I am done with the stages of development life cycle. Let us start with top-down design. Okay, we will live the rest of our syllabus in the design stage. Okay, first let us say what is meant by top-down design. We already have an idea because this structure chart represents the process, or it comes as a result of the process of top-down design. What is meant by top-down design? Let us go through it because you already have an idea what top-down design is. Top-down design breaks down a system into successively smaller pieces. Top-down design is the breaking down of a computer program into a set of sub-programs, then breaking each sub-program down into a set of smaller sub-programs until each sub-program is simple enough to be programmed. Okay, this is the diagram. This diagram is called structure diagram, or sometimes they called it structure chart. Okay, and this is the documentation of your top-down design. You split it into modules, and then you draw this diagram to show the relationship between modules. This is going to be a module. This is going to be a module. There are benefits behind this. First, a big problem would be split into a set of smaller problems that you can program easily. Also, you may divide tasks among several programmers because now the program is split into parts. So you can divide tasks and work concurrently or in collaboration. Okay? Okay. Advantages of using top-down design. When large computer programs are being developed, top-down design has the advantage that several programmers can work simultaneously to develop and test different sub-programs. Each small part of this will be called a sub-program or a subroutine or a module. Later on, I will say that to you, a module would be a function or a procedure. This is all our discussion today. Okay, we will be discussing these today, inshallah. Okay, so several programmers can work independently to develop and test sub-programs for the same big program at the same time. This reduces the development time. When you do top-down design, you will create a structure diagram or a structure chart. Okay, this is an example of a structure diagram or a structure chart. It shows how the program is split into parts. It shows the relationship between parts. It's a documentation for your top-down design process. Structure diagrams can be used to show top-down design in a diagrammatic form, so you draw diagrams. A structure diagram shows the hierarchy of different components which make up a system. The structure diagram shows the design of a computer in a hierarchical way. If you can see some repetition in my wording, you can say that these are copied from two different marks. Okay? A hierarchical way, with each level giving more detailed breakdown of the program into subprogram. A structure diagram gives an overview of a program or subroutine. You can get here an overview of your program. Example. That example was in the exam. A satellite navigation system is an example of a computer system that is made up of subsystems. The structure diagram shows some of each system. Actually, in the exam, they wrote for you a description of what needs to be done, and then your task was to draw a diagram that looks like this. Okay? So, for example, a satellite navigation system would be split into parts. First part is input destination. Second part is output. Second part is output direction. Okay, this is the process of top-down design. And then you go to input destination. I say I can still split it even into smaller parts. And they say, okay, input destination will be split into new destination or save. And then you create the subprogram new destination separately and the subprogram for handling save destination separately. This is modular programming. Also, output direction would be either on a map or a list. Okay, that was an example. Another example, alarm. This example is copied from the textbook, so it's not taken from an exam. However, it is very important to understand. Okay, alarm application. You split it into a subprogram to set. I'm repeating words that we will need to be dealing with. This is called a subprogram. Because when it comes to defining a subprogram, I don't have to define it anymore for you. So this is a subprogram or a module that is part of a program, not the whole program. Okay, so alarm, this is set alarm, check time. Check time is no further split. I can give a reason why. Sound alarm. Set alarm is split into set time, turn alarm on and off. Check time is not split. Because I would introduce you to what I'm going to say shortly. Set time would be a library module. What is meant by a library module? It is already pre-written in the programming language. You only need to use it. We will be studying lots of library modules in the next lessons, inshallah. So it requires no further breakdown because you will be just using it. We will be just calling it from the library. Okay? And sound alarm may be split into play sound, check off, reset, whatever. Okay? Another example that was in the exam, and actually the way it was solved in the exam is little bit unclear. I am putting the mark scheme in front of you, but the examiner at that time was allowing any answer, not necessarily this answer. Because that answer doesn't make a lot of sense. And a food ordering system, let us study this. A food ordering system. So that was in the exam, and that was the mark scheme. Okay? And in the mark scheme, they just put marks for any splitting of the program in any order. It doesn't matter, as long as you understand the process of top-down design. So a food ordering system is an example of a computer system that is made up of subsystems. Okay, study this. Food ordering system allows the user to enter the details of the food they want to order. and to pay for the order. So user input, enter detail. So split into user input and display option, enter detail, and then order, enter the detail, and then order. Maybe here enter is referred to order, and pay, and also pay. So user enter details and order. It's not properly split into proper parts, but it doesn't matter. That was the mark scheme in that exam. Display food available as picture or list. So display option, picture and list. This is obvious. The structure diagram for the given parts of the food ordering. That was the mark scheme. It is just a sample mark scheme. However, if you split your program into any other pieces, they will award you because they are examining you that you know what is meant by structure diagram. Okay, in any way. Okay, let us look at this other question. It says a structure diagram is a piece of code that is available through the structure of a program. You have to say false because a structure diagram is not a piece of code. A structure diagram shows the hierarchy of the system. You tick true because really it shows the hierarchy of the system. A structure diagram is another name for an array. You haven't studied arrays yet, and definitely a structure diagram is not an array. Structure diagram shows the relationship between different components. Yes, it does. Okay, so that was about structure diagram. When you apply top-down design, you split your program into modules. Let us play with modules because now you have to study lots about modules. A module is a subprogram or a subroutine. They are all the same thing. Okay? However, they use it popularly with subprogram or subroutine. So I'm teaching you now what is meant by a module. And the best way to teach this is to run it using Python. You don't need to write Python code, but I need now running Python code in front of you to show how things working, because if I attempt to describe it, maybe we'll not be able to understand each other. And if you are interested somehow, go and write these codes on Python, just for your leisure or just for your understanding. Definitely, inshallah, you will not be writing Python in the file. Okay? A subprogram or a subroutine is a set of programming instructions. Any program is a set of programming instructions for a given task that performs part of a program. So a subprogram or a subroutine is part of a program, not the whole. Otherwise, it wouldn't be called sub. Okay? No, not the whole program. A subroutine is self-contained code. I will later on, I may emphasize what is meant by being self-contained. That is called, being called. I will show right now. I am writing this code to tell you how a subprogram needs to be called within the program. A subroutine can be reused by another program. Okay, this is a benefit. You can reuse subprograms by other programs. Okay, let us first show you a module definition and then show you a module code. Okay? Let me copy these two modules into Python. I don't need to spare your time. I can just copy and paste. So now print hello world is in the main program. Okay? And in the main program, I have def is Python instruction to define a subprogram. I have a subprogram called say hello. If this subprogram is called, you need to call it. It will write welcome to program. And there is another subprogram that is say goodbye. And when you call it, it will say goodbye, my friend. Okay, let us run the program. Let us run of the program. Okay, print hello world is performed and the output is hello world. However, none of these is performed. Why? Because we haven't called them yet. What is meant by calling them? Write their name in the main program. This instruction is in the main program, but this is a sub-program that needs to be called from within the main program. And this is another sub-program that needs to be called from within the main program. Okay, let us attempt calling them. I will call say hello. This is in the main program and say hello. So it will say hello world. This will not be done. This will not be done. When you call, it will go and perform, say hello and come back. Let us run it. See, welcome to programming is performed. But say goodbye is not performed because it hasn't been called yet. Let us call say hello again. Okay, we can call it several times. And this is the benefit of using modules. You may call them several times. Okay, okay, as you can see, welcome to programming is called twice. But say goodbye is not called. Let us call it once. Let us call it once. So here at the bottom, this is what is meant by program calling. So you call say hello once, twice, and then you call say goodbye. See? So hello word is in the main program that will be performed anyhow. Okay? This will not be performed until being called. This will not be performed until being called. Because this is a sub-program. Or this is a subroutine. Or now this is a module. Later on, I will tell you that a module would be a function or a procedure. This is exactly what I have to say today. Okay, and this is calling say hello, so it is performed. Another calling for say hello, so it is performed another time. And a calling for say goodbye, so it is performed once. This is my way of explaining for you what is meant by module definition. This is module definition. And what is meant by module calling? This is module calling. Okay? Modules or subroutines written in high-level languages are called functions or procedures. We will come to that very soon. Actually, this is a module that is classified as a procedure. A function is a subroutine that always returns a value. This procedure does not return a value, so I am calling it a procedure. What does that all mean? I will show. Sounds complex, but I have my tools. I have written codes to clarify everything. Okay? A function, but please, please keep your eye on that because we will be going through it much more in details. But first, know a function is a subroutine that always returns a value. What is meant by that? I will show. I can say that, for example, function max calculates the maximum and returns it to the original program. Function minimum calculates the minimum or finds the minimum and returns it. Function average calculates the average and returns. So these functions are performing calculations and must be returning values to the original program. On the other side, a procedure is a subroutine that do not have to return a value. Maybe it doesn't do calculation, or maybe it just prints the result on the screen. So please study this very well, because this is very important in your study. So, because a function is a procedure that returns a value. I will have a separate topic here called functions. Okay? A procedure is a module, a subroutine that does not have to return a value. I will have here procedure. Okay? So now you have to know that. A subroutine could be a function or could be a procedure. A subroutine as a function always returns a value. A subroutine as a procedure does not have to return. Let us go through this example because it tests your knowledge, how accurate they are. A subroutine is called from within a program. I hope now you understand what is meant by being called. So you say true. A subroutine is not a complete program. It is true. A subroutine is self-contained piece of code. This is written in my notes, but actually you haven't witnessed that yet. Just say true, and we will go through it into more detail. A subroutine must return a value to the code from which it was called. This should be false. Why? This should be false because a subroutine could be a function or could be a procedure. If a subroutine is a function, it will return a value. If a subroutine is a procedure, it doesn't have to return a value. So you cannot generalize and say a subroutine must return a value because it may be a procedure that do not have to return a value.